Alright, today we're going to start a topic of definition of derivative. Derivative is one of those key words that we're going to hear all year long. It is one of the bases of all calculus. So this is huge. And it's important that we understand what derivative means before we start learning all the tricks to finding derivatives. So the first thing I'm going to do is just put a definition on this. And a derivative can be written as f prime of x. It can be used to say we're going to find the slope of the curve. And most of the time we'll say find the slope of the tangent line to the curve. So I'll write that word in there, slope of a tangent line to the curve, to a curve. The only thing we can't find derivatives at are the endpoints, cusp, which would be like a wave, so something that comes up as a point, corners, and asymptotes. These things are considered not differentiable, and we'll go much more into detail as we continue with derivatives. But I want to go ahead and throw out some of these terminologies. Differentiability means you can find the derivative. These four items are not differentiable, meaning you cannot find the derivative. So what is the logic of the definition of the derivative? Well, I mentioned to you that it's the slope of the tangent line at a certain point. Well, the way you're going to find the slope of the tangent line, maybe I need to define tangent line first of all. A tangent line is something where you have a curve and a line comes across and brushes it just at one point. Okay, we could actually find the slope of this tangent line of the curve, which would be finding the derivative. So how do we find the slope of a tangent line? Well, the logic behind it is to take secant lines, so lines that pass through the curve in 2 points, and we start finding the slopes of each one of these. And we are going to do that until it gets really, really, really close together. So I'm going to use another word that we've just been hearing, which is limit. We're getting closer and closer and closer to this point. So we're making our secant lines go closer and closer to our dots, get closer and closer together. So what that's going to give us is the definition of derivative. But before we can do that, what we're going to do is we're going to define the slope of the secant line. So if I was to draw a line, which I don't know how well I'm going to do here, that went through these 2 points, okay, this green line, it would actually be defined as f of x plus change of x minus f of x over change of x. Now these change of x's are just another type of variable. You could write y there or h's. A lot of what I'm going to do is write h there instead of the change of x because it bothers people to see the change of x. But I want to mention it to you now. Slope has always been rise over run. That's not going to change. It's always been y minus y over x minus x. So let's look at these 2 dots, or these 2 points. If I look at their y coordinates, right here and right here, here's my y2 f of x plus change of x minus my y1 f of x. All over, what's my x2? Well, right here, x plus change of x minus x. So right here, how does this simplify? Well, the top doesn't change. But the bottom has x plus change of x minus x, so these actually cancel, and that's why there's just a change of x on the bottom. Now, where did these function values come from? Some of you may be asking yourself that. Well, this value is x, and then what I did to get this value right here was I took the x value plus, we moved so far along this curve, some change of x. We added some amount. We could also call that h. Here, my function height, my y value is f of x. Well, here I'm not plugging in just an x, I'm plugging in an x plus change of x. So hopefully this gives you a sense of where the slope of the secant line is coming from. And now what I want to do is move towards the entire definition of a derivative, which has that limit in it. So what we're going to do is we're going to move these points, move this secant line closer and closer and closer and closer and closer until we get this tangent line to the curve. So we're making this change of x be about 0, okay? So we want this to be, as it's approaching 0, as this is getting smaller and smaller and smaller, what happens to that slope? That will give me the derivative of f of x. Now, I don't expect you guys to know all of this or have a complete understanding of this after listening to this one time. But it is something that you're going to want to go back and re-listen to and ask me many questions in class about. Alright, the next part of this video, I want to talk about all the synonyms of derivative. Derivative means slope m dy over dx, y prime, f prime of x, and then of course the definition of derivative. The limit as change of x approaches 0 of f of x plus change of x minus f of x over change of x. Now I told you I was going to slightly change this because you will see me start to use h's just because it tends to be easier for some people. So I'll say the limit as h approaches 0 of f of x plus h minus f of x over h. This is the same thing. So this is the same. Synonyms for average slope would be the secant, the slope of the secant line, the average rate of change, the change in y over change of x, which is the slope, y minus y over x minus x, and then here is that part right here without the limit in it. So that's the part where I showed you how to find the slope of the secant line. This first problem that we're going to look at, we're going to actually go back in class and look at number 2 in our book, and we'll do this together. So please leave a little spot for that. You can actually try it on your own at home, and then be a little bit more prepared for it during class. This next part we're going to do, it says to place a greater than or less than symbol between the quantities. So right here, let's look at what this means. This is really just slope of function y minus y over x minus x. So they're asking me, what about the slope of this? So from 1 to 4, let me go ahead and do that in red. How would we say that this slope compares to, let me go ahead and make 3 is about right here. How does it compare to the slope between 4 and 3? Well, I would say the red line is much steeper, so it has a larger slope than that of between 3 and 4. This is less steep, so I would place my inequality sign in that direction. This next question then asks the slope of the secant line between 1 and 4, which is that red line right here, and the slope of the tangent line. Let's go and do that in green. So the tangent line, the curve, would look something like this, where it just brushes up against that point. Oops, I've got the wrong point here. I did it at 4 instead of at 1, so let me go ahead and get rid of that. So the slope of the tangent line at 1 would be down here. Well, I can definitely say that this slope is less steep than the green line. This has much steeper slope. So that the inequality sign would be facing that this is less than, the slope of this is less than the slope of the tangent line to the curve. That's what f prime means. Derivative or tangent line to the graph. Let's go ahead and look at this particular problem. It's asking me to find the slope of the tangent line to the graph. When they're asking me to find the slope of the tangent line to the graph, they're asking me to find the derivative. So we're going to use the definition of derivative. Now they're going to use the h definition rather than the change of x one. They're the same thing. What it's asking me to do is find this limit. Well, my f of x, what they're telling me to do is plug in x plus h for all my t values. So I now really have the limit as h approaches 0 of x plus h squared plus 3. Minus, so that's what f of x plus h is, minus f of x. F of x is x squared plus 3. all over h. So take a moment, pause this, look and see where I got all those pieces of information. At this point, what I'm going to be doing is just using algebra skills to simplify this. So I'm going to FOIL this, x squared plus 2xh plus h squared plus 3 minus x squared minus 3, distribute that negative 3, or that negative all the way through. Those cancel, the 3's cancel, and I'm left with the limit as h approaches 0. What I'm going to do is take out an h here, factor that out, and I get 2x plus h over h. That allows me to cancel the h on the bottom, which will now allow me to just use direct substitution to find my answer. So when I use direct substitution in for h, I get 2x plus 0, and so my answer is 2x. Now, this gives me the slope everywhere at any point along the curve, but I'm asked to find the slope at this particular point. So the only thing left to do is to take and plug in negative 2 for my x value, and that gives me the slope of negative 4. Alright, in this particular problem, not only does it ask me to find, it's not just saying find the slope of the tangent line, it says find the equation of the tangent line to the graph of a function at the specified point. So the first thing I need to do is find the slope of the tangent line, because I can't write an equation of a tangent line without having a point and a slope. So this is the equation of any line. I could start to write this equation by going y minus 2 equals, this is what I need to find, x minus, and so it ended up being plus 2. So this is the start of my equation of my tangent line, but I'm missing my slope. So I'm going to need to find f prime of x, which is derivative. So I use the derivative definition. So I'm just copying down the definition of derivative. This is something that you should memorize. And then I'm going to apply the definition of derivative. So it says find the limit as h approaches 0. Plug in x plus h in for all your x's. So you've got x plus h squared plus 3 times x plus h plus 4 minus whatever your f of x is, which is this x squared plus 3x plus 4 all over h. Simplify using algebra. So you have x squared plus 2xh plus h squared plus 3x plus 3h plus 4, FOILed here and distributed the 3 through, minus x squared minus 3x minus 4 all over h. At any point in time, pause, look at what I'm doing, then go back to the problem. So looking at what cancels on the top, I've got x squareds cancel, I've got 3x cancels, I've got 4 cancels, and I'm left with 2xh, h squared, and a 3h. You should always be able to factor out an h on the next step once you've canceled. So h factors out, and you get 2x plus h plus 3h, or no, just 3, all over h, and so your h's cancel. Use direct substitution, and you end up with 2x plus 3. Now remember, this is the derivative at any point, but I want to find it at this particular point, so I'm going to plug in negative 2 for my x, and I'll end up getting negative 4 plus 3, which is a negative 1. So that means that my equation of my tangent line to the curve would be y minus 2 equals negative 1 times x plus 2. Now I could put this in a different form, or I can leave it in that form, but any of those are correct for an equation.